Hi, I'm Sunday Sylvester Nassau, and today in this video we're going to discuss some chemistry, chemical decomposition, and also I'm going to go into some exercise on it. Let me say example under it, and when we are done with it, and make sure you know that this topic is not actually sometimes direct question. You just see like they ask you when if I can hit on this one, what will be the product or what. Sometimes it really comes inside a trick question that you need to apply this topic knowledge of this to be able to answer it. I'll show you one simple one, but there are a lot of it there, right? So understanding this topic is very important, right? That's it. I'm going to show you that one. I'm also going to show you another one there, right? From not from past question, but I'm just going to help you with it there, right? So for chemical decomposition is the effect of heat there, right, on a compound. Some compound will decompose to form different 2 or 3 or more, so more new compounds, while some will not decompose, some will just melt if you keep heating them, evaporate or sublime. So so we're going to discuss only for the ones that will decompose on heating, not the ones that will melt, right? So this is very important topic to know. And without waste of time, first I'm going to introduce the electrochemical series because it's very important in this topic, because I'm not going to give you each of the elements like this what they do, this what they do. I'm not going to give you each of the elements. I'm just going to group it, and the best grouping is when you use the electrochemical series. So I'm going to show you some mnemonic of electrochemical series. If you already know it or you have your mnemonic, you don't need it. But if you don't know electrochemical series, or you know it but putting it in series is kind of like hard for you, this is the chance there, right? Use this and get your answer fast. It's very important. I'm going to show you that. So let's go to it so I can group it together there, right? So let's go to electrochemical series here. I'm just going to take up the picture there, right? So you have this there, right? And you can see I put it in 2 rows there, right? So let me divide it like this. So if you come down, you're gonna take from public down to authority again, because the space won't be available for me to write it in just 1 row there, right? So let's go without waste of time. You can see potassium, sodium, magnesium, calcium before magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, iron, silver, and gold today, right? So to put this thing in series is kind of confusing, but if you use this mnemonic, you know this few statement, you're done, right? And it's very easy. Just king NASA cannot magnify all zonal forces since public hydrogen corrosive mercury fights against authority. You can see it's very long, longer than the having the elements, yeah, but it's cool, right? If you know it, it should be fast. I just do it gradually, so to get all of the words clear, right? So but if you know it, you play with it, you memorize it, you can do it fast. Like King NASA cannot magnify all zonal forces since public hydrogen corrosive mercury fight against authority. It's very easy to grab, right? The first time my uncle gave us this, I was like, oh, this thing is another problem there, right? But as I just attempt to learn it, it's very easy to know it there, right? When especially you break it down there, right? And it really helps, so you will be sure of what you're doing with this, right? So when learning it, break it like King NASA cannot magnify, King NASA cannot magnify. After singing that one, you go to all zonal forces. You grab that one, you combine the two. King NASA cannot magnify all zonal forces. Then you go to the middle one, which is kind of like wrapping there, right? Like since public hydrogen corrosive mercury. I think that one is very cool, right? So you take your time and understand this one very well. While the last one is actually the easiest among them. That's fight against authority. So there's no any doubts and waste of time here, right? So after knowing this thing, but I should figure something out here, right? You can see there are two ions there, right? Ion 2 and ion 3 there, right? Actually, in the textbook, we don't really consider ion 3 here, but because of to make the trick easier, we really involve it here, right? Yes, it's the position for ion 3, but if you like, you don't put it there. But to make the mnemonic sweet, like fight against authority, don't just against authority, it's not sweet, but if you say fight against authority, it's very sweet like that. So ion 3 is there, but if you don't want to put it, don't put it, nobody will question you there, right? And if you're getting confused, which one is the first? Is this ion 2 or ion 3? Here is the catch there, right? You can see from S block there, right? You can see from S block from potassium, sodium, calcium, and magnesium. The ones with the lowest oxidation, or that's the one first in group 1, that's the one with +1, are the ones on the top. You can see them there, right? The calcium, the potassium, and the sodium. While the calcium and magnesium have bigger oxidation number, so they are the ones on the bottom. So the one that have smaller will be the one on the top right? While the one that have bigger, that's 3, will be the one on the bottom. So that's how you use it to remember it, right? So use the sense of this, right? You know that the ion 2 is more reactive than the ion 3. And again, you can see the corrosive here is actually CO, but I'm sorry, copper is actually Cu there, right? So don't think of cobalt, we're using copper. If you already know that it is copper we're discussing here, because that's the only word that is suitable for copper in this list here, right? So you know that actually corrosive represents copper. So there's no anything hard there, right? So without waste of time, let's go into um, each of them there, right? And again, thank you. Let me introduce the groups in there, right? Let me give the grouping, which is very, very important here. So the grouping here I'm going to do is just that I'm going to group it into just three, easy to grab there, right? If you group them, you group these plenty things in just three. It's actually a very easy thing to do, right? So first, the grouping is just know something I call C to C, right? If I just mention C to C, I just feel okay because I love it, right? C to C really group everything here. So C to C, that means from this C to this C of copper, from C of calcium to C of copper. So from C to C is actually one group. So here to this place are actually one group. So they are C to C. So you can see now a group on the top and a group on the bottom. So that's how we divide it, right? So these guys are of same group with these guys there, right? It's just that I have to put it in it enters the other row. I cannot put it in a straight line. These are actually under there, right? So let me close this one. So from C to C, that's all you're gonna know. So the ones on the bottom are the top and the ones on the bottom. That's the only thing there, right? No any doubts, no waste of time. So if I mention C to C, know that I mean anything inside this thing like magnesium, calcium, aluminum, zinc, tin, iron too, lead, hydrogen, and even copper. So those are the ones there, right, that involve C to C. So I'm not going to be mentioning them name, I'm just going to say C to C. And the ones on the top, I'm just going to say the ones above C to C. Those are the potassium and the sodium. While the ones below C to C are the mercury, iron 3, which we're not going to discuss inside our working, just silver and gold. So mercury, silver and gold are the ones below C to C. I think the grouping is very, very easy to grab there, right? So let's move, right? So first, I'm going to, now since we already know the electrochemical series, now I'm going to take the anions one after the other. I'm going to start with the nitrites, then go to the carbonites, the right, go to sulfites. Also, I'm going to discuss some ammonium salts because it's very, very important. Let's take on the nitrite first, there, right, which is very, very important there, right? So nitrite is actually NO3, 3, -1 there, right? So nitrites is that one thing to know is that all of the nitrite decompose on heating there, right? So first, the first group, the ones above C to C, I'm going to represent potassium with it, right? We have potassium and sodium, but I'm just going to take one of them and go with it here. So potassium nitrite will decompose to give you. So one thing you should know with potassium, the ones above the C to C, that's potassium and sodium, is that when they decompose, they only try their best to give out oxygen. So that's what I want you to learn on this, right? They try their best to give out oxygen. So when this one will decompose, doesn't really give out the nitrogen, but it gives out the oxygen. So nitrogen dioxide now, because give part of the oxygen now. So oxygen gas is given out, so you still have potassium nitrite, potassium dioxynitrate, nitrite. Right, you can see that that's how the name is, right? This one is potassium trioxynitrite, but this one is potassium dioxynitrite. There, right, is 2 oxygen, that's dioxynitrite. So that's how it is there, right? So the next one is C to C there, right? The group of C to C. I'm going to take one example as calcium there, right? So calcium nitrite, when it decompose, so this is what it's going to give. The group of C to C are the ones that will give out the non-metal. So that's what I want you to know. First, I say the ones above C to C, they give out oxygen. Now the ones in C to C, they give out the non-metal, right? So if you give out the non-metal, they still have the oxygen attached to them there, right? Keep that in mind. So the non-metal is giving out, so NO2 you're giving out 10 plus oxygen already giving out there, right? So their own duty is to separate this one there, to break this one. This thing is already broken, so their own is just to break this one, right? I think you're following this, right? So so let's go the next. The ones below C to C, let me take example with silver nitrite will decompose instead of calcium oxide, so silver oxide will decompose here, right? To form silver plus oxygen there, right? Then plus the non-metal oxide that was decomposed by the C to C, right? Plus the other oxygen, but no need of putting another oxygen there, as we just have it there. So let me show what I really mean here, right? If look confusion, let me show it as a paper and explain it there, right? But I try my best to give the easiest way of knowing it there, right? So this is actually what I mean here, right? So you can see that let me get a good, yep. So you can see nitrite is it the first above C to C, they give out oxygen, right? Now the ones in the C to C, they produce the nitrogen dioxide, while the ones below the C to C, they split to this thing. So they split it and form Ag, that's the metal, and the oxygen gas, right? So instead of oxygen, another oxygen here, we just write it in ones there, right? Then you balance your equation or put any numbers there to make sure you balance it. So that's what I really mean by the composition of nitrogen, right? So without waste of time, let's go to the next thing. This is all I want you to grab there, right? If you really understand what I mean, it's very hard for you to forget this, right? Because you just do it in remember a series. First, the ones on top will give out oxygen. The C to C now give up the non-metal oxides. Now then the ones below will decompose this thing. Their metal oxide are not stable on heating. They decompose, right? This one is stable on heating, this one is stable on heating, right? So let's go to next thing there, right? Let's go now to carbonite there, right? Carbonite. That's CO3 -2 or 2 negative there, right? Let me change this here, right? So carbonite, let's start with the ones on the top there, right? So one interesting thing you should know about the ones on the top, the potassium carbonate or sodium carbonate, is that they are stable to heat there, right? So these guys are stable to heat. No matter how you keep heating them, they will still remain the same thing there, right? So this a little bit of shortcut, no stress there, right? So sodium and potassium are stable to heat. And look at what cause here. I want you to pay attention and understand here. So since this guy could not produce the oxygen, the C2C will only produce the non-metal oxide. They don't care, right? So you have calcium oxide plus CO2. So instead of oxygen plus oxygen, these guys have not produced the oxygen. So that's how it looks. It will stay. Remember? So what I'm trying to explain that one is because I want to make this place clear there, right? Because it's confusion. You know that the calcium nitrite give you calcium oxide plus nitrogen gas plus oxygen. So you can see there is oxygen here and there is no oxygen here, right? So what will help you to remember is that the ones above the C2C of the nitrite produce the oxygen, while the ones above the C2C of the carbonate they don't produce oxygen. So that's why it stopped like this. Wow, I think it's great, right? You're getting it? So now let's go to the next thing there, right? Let's go to the ones below the C2C there, right? So the ones on the C2C, we say it produce calcium oxide plus the CO2. Now the ones below the C2C will produce, this thing will split there, right, for their own. So you have Ag plus oxygen gas plus, now you can see where oxygen gas come from there, right? Because this gas split. Wow, I think this thing is really enjoyable there, right? You can see the reason why there is oxygen here and there is no oxygen here, right? Very great here, right? So very easy. I believe this one is already understood here. So now let's go to the next one. The next one is actually sulfite there, right? So one thing I want you to know is sulfite is that sulfite is actually stable. Most of them are stable. Those electrochemicals C2C will only work for the nitrite and the carbonite there, right? For sulfite, it's actually potassium, sodium, calcium are actually stable there, right? For sulfite, they don't decompose on heating. Our textbook did not mention much thing. I've gone to the internet, I couldn't see anything much about sulfites there, right? As I said, most of them are stable to heat, but not those three. They are the ones that were mentioned. But the ones that decompose on heating is actually copper, zinc, and iron there, right? Copper and zinc have similar decomposition there, right? So copper and zinc there, right? So let me give it example just with copper. So copper sulfite, this copper. So it decomposes to give you the copper oxide plus the SO3 there, right? Please remember SO3. Just know that one of the oxygen is here. So remain 3 there, right? It's not the best thing of knowing equations. It's very at risk there, right? But I just want you to use it only for this case there, right? Because sometimes you do confuse and say it's SO2 there, right? Because most of times we meet SO2 in our solutions there, right? So this is wrong in this case there, right? It's SO3. So but you can remember that one of the oxygen is gone and this there. because if you put SO2 here, it can never be balanced here, right? Make sure you know it. You can never balance it with this there, right? You can, if you like, you try it, right? Try to balance it like this, you sweat. So I don't want to try balancing it here because it will waste our time here, right? You'll see how it will not work. So let's go to the next one. Is actually iron 2 sulfite. So when iron 2 sulfite decompose, it's actually 4 decompose, give an interesting thing there, right? Is to give out the iron 2 oxide plus SO3 there, right? But it's very good to produce SO2 as well. So these are the additional ones you produce from iron 2 sulfite. If you do it like this, it can be balanced. It's very sure you can balance it like this, no doubt there. But the one you don't have this one, but you just have 2 here, it will never be balanced. So just keep that back of your mind. So that's for sulfite there, right? Without waste of time, let's go to the next thing. Next one I'm going to discuss is chloride, the one with D there, right? Let me call it, let me write it. Chloride there, that's Cl minus. So chlorides are actually stable at heat there, right? So all chloride are stable on heat. So this one, there is no waste of time, no doubt, no any tricks to put in your mind on it there, right? Just know that all chloride are stable on heat. None of them decompose on heat in there, right? So all of them, like calcium chloride, when you heat it, it still remain calcium chloride, maybe from calcium chloride solid, which will just melt there, right, and turn liquids there, right? Same thing to copper chloride, it will just turn to copper chloride liquids there, right? Anyhow there, right? That's what I really mean with it, right? So no waste of time. Calcium metal chloride are all stable on heat in there, right? They don't decompose. So now what about chloride? That one is chloride, this one is chloride. Let me write it. Chloride, thank you. So it's ClO3 LO3 1 minus there, right? So how about the composition for this ones there, right? Well, this one is also general. It have general, all do the same thing, so I like it. So because all chloride are stable, this one really help. So you can see this potassium chloride ClO3, they gives out oxygen. Yeah, you remember they are the ones that give us oxygen there, right? So when they give out oxygen, they give us oxygen. In this case, they give out all of it there, right? And that's what you really need to grab. So they give out oxygen and form something like this. So if you form something like this, the next guys also C to C also will give out oxygen there, right? This thing you have 2 here, right? It also give out oxygen and form something like this. So almost all of them, I say just all of them, they decompose to give you metal chloride plus oxygen. Metal chloride plus oxygen is very important there, right? And it also use this in production of oxygen. If you remember in your oxygen metal non-metal on their compound, you see this equation there, right, in producing oxygen. So all metal chloride decompose to give you metal chloride plus oxygen gas there, right? Chlorides, metal chlorides decompose to give you metal chloride plus oxygen gas. We got a different pronunciation of these two guys there, right? And these chlorides, but this chloride with D. Thank you. So that's for these ones. You see, with the knowledge of knowing all chlorides are actually stable on heating. That's why even Ag, they don't decompose on heating there, right? So their chloride will be Ag chloride plus oxygen gas there, right? So this one don't decompose on heating there, this Ag. They don't decompose on heating there, right? That's good. So let's go to the next thing. The next one we're going to discuss is the ammonium. The ammonium is actually NH4 plus there, right? So ammonium is actually a cation, it's positive. So we're not going to refer we're going to our electrochemical series. All we need is just comparing it with the non-metals there, right? The sulfide, the nitrite, the carbonites there, right? So and I want you to remember about ammonium. Is very interesting and easy to remember, right? It's just that all ammonium salts decompose to give you ammonia and the respective acids there. So it's very great to know that. So ammonium, for example, ammonium chloride will decompose to give you ammonia plus the respective acid. The acid for chloride is actually hydrochloric acid there, right? So you can see it there. It's very easy to know it like that, right? So same thing to ammonium hydroxide and H4OH. It will give you ammonia and H3 plus the acid of the OH is actually water there, right? Let's go next. NH4, this should be 2 of sulfide will actually decompose to give you NH3 I mean, plus sulfuric acid there, right? This sulfuric acid space won't be enough there, right? Also the carbonic acid, so NH4 2 CO3 there, right? To give you NH3 plus H2 CO3. But you should know that if you are hitting this guy also decompose there, right? So instead of stopping there, it will continue there, right? From NH3 plus water plus CO2 there, right? So that's what I really mean there, right? So this one will decompose to give you water and carbon dioxide, right? Just like in your neutralization of carbonates there, right? Like sodium carbonate plus hydrochloric acid, it will give you sodium chloride plus water and CO2. So the carbonic acid will actually decompose to give you water and CO2. So that's why in your textbook they won't stop here, but they will stop here there, right? And even though you're asking your equation in your exam, don't stop at this there, right? Because this one decomposes also on heating, right? So that's for these guys, and they're very cool. They give ammonia and their acids, but it has exception there, right? So the exception is actually for the nitrite, like the ammonium nitrite, ammonium trioxonitrite. Instead of the composite form ammonia and the respective acid, it forms something different, right? It forms laughing gas plus water. So this is what it formed, right? Laughing gas plus water. And you can see if the oxygen here is reduced to NH4 NO2, so instead of having oxygen here, we're just going to have N2 plus the water there. So you can see that ammonium trioxonitrite decomposes to give you laughing gas and water, but ammonium dioxynitrite decomposed to give you just nitrogen gas plus water. This is used in production of laughing gas, and also this is used in production of nitrogen gas. It's very important because in preparation of nitrogen gas you actually meet these guys there, right? It's very important to know it. So that's all for ammonia. Also remember that ammonium heptaoxochromate don't decompose to give you ammonia, and this it also follow the rule for ammonium nitrite there, right? So those two guys, their own is different, so yeah, exception for each. But all other ones is actually they will give you ammonia and the respective acids there. So that's cool for them there, right? So no waste of time, let's go into some questions there, right, and answered, so we can understand what we did there, right? So an easy question to grab there, right? So let's go now. They say on heating, which of the following compound will decompose, we change the color, will decompose to form a free metal, nitrogen 4 oxide and oxygen. This guy is a part of C to C there, right? So you're going to form calcium oxide plus the NO2 that they would remove plus the oxygen gas that was already given out by the ones above C to C. So this guy will form its metal oxide decomposed to give you metal plus oxygen gas, then plus the NO2, right? While this guy will just form NaNO2 plus oxygen. You just give out oxygen there, right? Plus oxygen gas. So it's only this one that form free metal. What's the meaning of free metal there? I just metal on its own there, right? No anything attached. Nitrogen dioxide, and that's nitrogen 4 oxide if you like, and oxygen. So option C is the right answer for this question there, right? So easy. So let's go to the next question. So the next question is which of the following compound of trioxynitrite 5 will decompose to give the oxygen dinitrogen 1 oxide and water when heated? So we have already given this one. I don't want to be wasting time on them there, right? But for good understanding, let's continue writing it. These guys will have the same thing because they are part of C to C there, right? So they will form zinc oxide plus NO2 plus oxygen gas there, right? While this one will form N2O and 2O plus water there, right? And that's what the question was asking there, right? The oxygen 1 oxide and water. So it's this option that will produce that there, right? So without waste of time, we are done. Hope you're seeing how the question is to comes out there, right? So watch out how to answer a question on decomposition there, right? They're very simple. So this one is which of the following is not decomposed by heat? So which of them is stable, right? We already discussed that carbonite, the ones on top of the C to C, are actually stable at heat there, right? So they will only melt there, right? They don't decompose. While all these guys here are actually part of the C to C, including this one. So all of them they could decompose to give you metal oxide plus CO2 there, right? So that's it. Very easy, a waste of time. So here the next question is, what is the following compound, or which of the following compound will not decompose on heating strongly? So no matter how you are heating it, which of them will not decompose? I should mention that this thing is very important to know. This guy actually decomposes on heat. And the way I remember is that it will give you the one that don't decompose on heat, CO3, but it will give you just like the neutralization of the carbonites there, right? Give you water and carbon dioxide there, right? So remember it like that. Water and carbon dioxide are given off with the one that don't decompose. So don't just say because hydrogen is left, so you just say is this plus hydrogen gas is wrong there, right? Please know that these are the ones that will produce, right? How? So this guy is stable, but this guy is not stable because he can still produce water and carbon dioxide and this, right? While these remaining ones are part of the C2C, which we already discussed. So let's go to the next. So the next here we have is on heating, which of the following trioxocarbonate salt decompose to give a solid residue? Except, now they are giving us exception there, right? So which of them? Let's start from the bottom. This guy, all of them are part of C2C there, right? So they form metal oxide, and metal oxide, let me just write M there. Metal oxide is actually a solid residue there, right? Plus carbon dioxide, which is not solid residue, but this guy is solid residue. So how about this guy? This guy will decompose to give us ammonium trioxocarbon. We say give us ammonia NH3 plus the carbonic acid, which will decompose to give us water plus CO2 there, right? So you can see all of those guys here are actually gas here, right? At this temperature they are gas. So option A is the only option that will not give us a solid residue. So you can see this one is not really a direct question under this because you really have to know their stage there, right? Very important to know it. So now let's go to the next part. So which of the following triaxonitrous salts will decompose on heating to form a metal? Which of them? Well, we already discussed that this one will form a metal there, right? Plus the oxygen gas plus C plus NO2 there, right? So this one will actually form a metal. While all this and this will form metal oxide, while this one will just form metal dioxynitrate plus oxygen there, right? So it's only this that will form metal. So B is the right answer for this part there, right? So now let me check this interesting question for us. So you can see this question is good, right? You say a solid X when heated gives a brown gas. So if X is soluble in excess sodium hydroxide solution, but insoluble in excess ammonium hydroxide solution, then X is actually what? From the class that we did on test for cations, we know that soluble in NaOH, we say NaOH because of the A. We want to start with it there, right? So it's soluble in NaOH and insoluble in ammonium hydroxide there, right? So it's insoluble. So you can see we're using sin there, right? And we have only two sin, the all sin and the public sin. All sin is not here, so we thank God there, right? So the public sin, that's PB, is actually lead. So this test from here is telling us that this thing is actually lead. But how about the first one here? Because we see two lead in our option there, right? You can see two lead in our options there, right? So how will you know which one is the right one? Is from the first statement there, right? Which of them will decompose to form a to give up a brown gas, right? So now let's do their decomposition and see what will they form. This thing is really waste of time. Cleaning it is a problem. Yes. So now we say that this guy will actually give us a metal oxide plus CO2 there. Very easy. How about this guy? This guy will form metal oxide plus NO2 plus the oxygen already given out by the ones above the C2C there. So you can see that this guy is here, and this guy is actually a brown gas. You need to know colors also very important there, right? So nitrogen dioxide is actually a brown gas. So if you read nitrogen very well, you meet all of these things there, right? So option B is the right answer. So knowing just the test is not okay there, right? The decomposition is also very important, so you will know. And also the code, you can see chemistry is not just knowing one part and leave the others there, right? So very important to know them there, right? Now let's take this last question. Let's take this last question. I pick it from a past question paper. I copied it. So you have jamb 1988. If we check number 35, you see this question here. So the thermal decomposition of copper 2 triaxonitrate 5 yields copper oxide, oxygen, and what does it give here, right? So copper is part of C2C there, so they gives out nitrogen dioxide, they give out metal dioxide, you remember? So without even solving it, you know that's the answer, right? So nitrogen dioxide is same thing as nitrogen 4 oxide. So don't go and choose this one there, it's actually wrong. This is the right answer there, right? And O2. So if you solve for the oxidation number of nitrogen, you have 4. So that's why I use 4 here. But if you don't like it, you can call it nitrogen dioxide there, right? So that's it for the chemical decomposition there, right? Hope it's helpful and you see how to work it out there, right? I really want to summarize it first before we go, but time has already gone. But let me summarize the little I can there, right? First, we discussed on the electrochemical series. We discussed on King NASA cannot magnify all zonal forces since public hydrogen corrosive mercury fight against authority. And next, we discuss also on the nitrites there, right? So nitrite, all of them decompose. The metal, the ones above the C to C, they gives out oxygen, while the C to C will actually give the metal, non-metal dioxide. There, right? So in this case of nitrite, they will give nitrogen dioxide, while the ones below the C to C, their metal oxide would actually decompose on heating also. So they'll form metal only, non-metal dioxide, and oxygen gas. Now next we go to the carbonite. For carbonite, the ones above C to C are stable on heating. They don't decompose on heating, right? So since they didn't decompose on heating, they didn't give out oxygen. So the ones for C to C, when they gives out their non-metal oxides, they give out this carbon dioxide, they won't have oxygen there, right? So know their difference there, right? So no oxygen there. But now ones below C to C will actually have their metal oxide decomposed to give metal and oxygen gas. So this way you meet oxygen in the composition of carbonite. So that's it. And next we talk on sulfite, and all sulfite we say most of them are stable, and the copper and the zinc sulfite are the ones that decompose to give us the metal oxide plus the sulfur 6 oxide, that's SO3. While the iron 2 sulfite will give us the iron oxide, sulfur 6 oxide, but also with sulfur 4 oxide. Now if you discuss in a chloride, the one Cl with ID, with IDE, that's chloride, is actually stable at heat. No matter how you're heating it, it's stable, it just melts, right? So next we also discuss on chlorides, as ClO3 negative. They actually, all of them will decompose to give us the chloride, which is stable at heat, plus oxygen gas. So it's very easy to know that one also. And the next is actually ammonium. We say all ammonium self decompose on heating to give us ammonia plus the respective acid there. So if it is ammonium chloride, will give you ammonia plus hydrochloric acid. So except these ones that are nitrites, like ammonium nitrite, ammonium trioxynitride will decompose to give us laughing gas and what, while ammonium dioxynitride will give us nitrogen gas plus water. So that's it. And also ammonium heptaoxide dichromate will also give us the heptaoxide dichromate plus the nitrogen gas plus the water there, right? So that's how the taste looks like. It's very easy to grab, easy, no waste of time, and that's all for today, right? Thank you. I shall remain Sunday Sylvester, NASA.